In the last video, we discussed how memory is manually managed in C++ using new and delete. But manually allocating and freeing heap memory can be tricky and error prone. That's where smart pointers come in. Smart pointers solve this by encapsulating raw pointers in C++ classes that automatically free memory when they go out of scope. Internally, smart pointers still use new and delete, but you don't have to worry about it anymore. Unique pointer. A unique pointer owns a piece of memory exclusively. That means you cannot copy it. When unique pointer goes out of scope, the memory it was pointing to is freed. Let's say we have a unique pointer, test1, and it points to a memory address here, right? So test1 points to this memory address. And in code, this is the scope of test1. So test1 is defined here as a unique pointer and its scope ends here. Okay. In unique pointers, what happens is if test1 scope ends, then the memory it points to is deleted. Okay, it's freed up. But let's say we have a test2 defined here and test2 is copied into test1. First of all, this is not allowed in unique pointers, but I'm explaining why it's not allowed. So if test2 is assigned test1, and when test1 scope ends, that means this memory is no more here, right? If this memory is no more here, then still test2 will point to this. But as this memory is freed up, it will now point to a memory location that doesn't exist. That is why in unique pointers, copying is not allowed. This is a simple test class with a constructor and a destructor to track when objects are created and destroyed. Mind that including memory header is needed for working with smart pointers. Now, in main, we can create a unique pointer using the constructor. So, using constructor, this is how we can create a unique pointer. But notice that we are using the new keyword. Now, another and more efficient way to do that is using make unique. And using make unique, we can create a unique pointer. And this should be preferred because it prevents memory leaks in case of exceptions and avoids redundant new calls. So this should be preferred. Now, moving on from this, let's create another unique pointer, btest3, and assign it the value btest2. This is causing an error, which is it cannot be referenced as it is a deleted function. Now, remember we discussed that copy constructor of unique pointer is deleted. You cannot copy it here. If copying isn't allowed, how will we pass this to the functions? Because functions need to copy, right? So to do that, we have something called move, which transfers the ownership. You can transfer ownership of a memory using move. This means that the ownership is transferred and now ptest2 points to null and ptest3 is pointing to the memory which was earlier pointed by test2. At the end of main function, when the scope of all these pointers end, the memory will be freed. Now, if I create, say, this unique pointer inside this block, then that means that it is defined in this block only, and whenever it goes out of scope, the memory it is pointing to will be released.
So you don't have to use delete or new keywords explicitly. So in unique pointers, it's all about scope and exclusive ownership.
In the next video, we will see how to share memory using shared pointers.